EES, which is pronounced ease, is an acronym for Engineering Equation Solver. The other videos in this section introduce the use of the psychrometric property functions in ease and then use them to solve this simple air conditioning example. This video introduces the PsychProps procedure and illustrates its proper use in the context of this same example. The PsychProps procedure provides a coding shortcut that is helpful when you want to determine two or more psychrometric properties at the same state. This is almost always the case when you're analyzing a system like the one shown here. At the inlet, state 1, we need several different properties, including the dry air specific enthalpy, volume, the humidity ratio, and also the dew point. The PsychProps procedure is a lot like the real thermal props procedure that was discussed in the section on real fluid properties. An example of the correct calling protocol for the PsychProps procedure is given here. The procedure requires three inputs that together fix the state of this air-water mixture. Any valid combination of inputs is accepted, but one property must always be pressure. The substance name, air H2O, is not required, but it can be provided. The procedure PsychProps only works with the fluid air H2O. Each of the three inputs must be identified with the usual one-letter property identifier and an equal sign. So the list of the input property identifiers needed in the calling arguments and the instructions are shown here, and they're the same as any of the psychrometric property functions. The value and the units of the inputs and the outputs are determined in the usual way by the unit system setting. The PsychProps procedure will return temperature, dry air specific volume, enthalpy, entropy, and internal energy, humidity ratio, relative humidity, wet bulb temperature, and dew point temperature in that order, given any three properties that fix a state. So outputs can be skipped by just not populating that location in the output list. So for example, if you didn't want the procedure to return dry air specific internal energy, then you would just leave that item in the list blank as shown here. In order to illustrate the use of the PsychProps procedure, let's modify the example ease program developed in an earlier video to simulate this system. So here we separately use the functions humrat, volume, enthalpy, and dew point to determine these different properties at state 1. The PsychProps procedure allows us to replace these 4 lines of code with a single line. And the easiest way to do this is to navigate to the function information window and select air H2O from the thermal physical properties menu, and then we'll select the PsychProps procedure from the left box, and down here we can select the two independent parameters other than pressure, and in this case for state 1 we have temperature and relative humidity, and then we'll select paste. So we can modify the pasted code as necessary here. So you'll notice that the inputs that we're going to use are the same as they were for the individual function calls. Also, I'm not required to specify the fluid. And further, since I really only want 4 properties, humidity ratio, volume, enthalpy, and dew point temperature, those are the only spots in the output list that I'm going to populate. So it's relatively straightforward to do the same thing for states 2 and 3, which you can see has been done here. And if I then eliminate all the unneeded code that I've just gotten rid of, you can see that the example program has gotten a lot more concise, because I don't need to use multiple function calls at each state point anymore. And this can be very convenient for large programs that are simulating systems with many different states. So this is one of a series of tutorials meant to describe the operation of the ease software. If you'd like to get more information about ease, obtain the software, or access more of these tutorials, please go to the website fchart.com. These tutorials are excerpted from the book Mastering Ease, which can also be obtained from the fchart website.